Okay, so here we go. First off, thank you everyone for joining today's spotlight session on space engineering at Lassonde. My name is Anna. I am the domestic student recruitment officer at the Lassonde School of Engineering. This means that I have the opportunity to assist students like yourself in exploring the various programs we offer here at Lassonde and help guide you through the application and admission journey. I'm also joined by passionate members of our space engineering department and some current students who are excited to share more about their program today with you. Okay, so here's what we have lined up for you today. First, we'll hear from Lassonde's space engineering program. We will hear about space engineering from our department representatives, including perhaps some of your future professors. They'll provide an overview of the program, highlighting opportunities for students like yourself. Next, our current students will share some of their experiences in their program, as well as at Lassonde as a whole. Then we'll open up the floor for questions. So if you have any questions during today's session, feel free to put them in the chat or raise your hand in the Zoom. We will address them later on near the second half of today's spotlight session. Lastly, before we let you go today, we'll go over some ways to stay connected with us beyond today's session. So without further ado, I'll pass it off to our space engineering team to introduce themselves and tell us more about their program.
Okay. So hello, everyone. Thanks for joining. I'm going to share the slides here. Let me know if you can see them all right. Fantastic. Okay, so my name's Michael Bazaki. I am an assistant professor here at York in the space engineering program. We have a number of other people here on the call who I'd like to be able to introduce themselves before we start getting into the slides. So maybe why don't we start with Ryan?
Hi, everyone. I'm Ryan Orslick. I'm also an assistant professor in space engineering. My focus is on the applications of smart materials like piezoelectrics, shape memory alloys in space applications. Thanks.
Thanks, Ryan. Regina?
Hi, my name is Regina Lee. I'm a professor in space engineering. My research is on small satellites and satellite technologies. I work with a lot of colleagues in this room as well as outside of York University to keep an eye on our space environment.
Thanks, Regina. Ian? Oh.
I'll go first.
Sorry about that.
I'm Ian Tomaszewski. I am one of the lab technicians here in the department. I'm also a graduate in the engineering program 2015, or space engineering program 2015. And I'm also a graduate student in the department, doing research with smart materials and robotic arms and hands.
Thanks. And then why don't we do the three students in alphabetical order by first name? So I think Connor, you're up first.
Alrighty, so I'm Connor. I am a now fourth-year space engineering student, currently working in Regina's nanosatellite research laboratory. So in space engineering, I'm focused on space situational awareness. A lot of my work is on the simulation side of things. So predicting what's going to be happening within the space environment in the future. And I've participated in certain clubs such as the Lassonde Engineering Society, as well as the Robotics Society at Lassonde.
Hi, my name is Ian, the other Ian. I am the Space Engineering Ambassador for this summer. So you'll be hearing a lot from me. I also work in Dr. Lee's lab. I am doing orbit determination, which is just determining where the orbits of satellites are. I have also worked on the Essence CubeSat mission, which launched about a year ago now.
Hello, I'm Marissa. I am a upper year space engineering student going into my fourth year. I also work in Dr. Regina Lee's lab. and I work on attitude determination technology with the use of star trackers. So basically determining your orientation with a photo of these stars in simple terms.
Great. Thank you, Connor, Ian, and Marissa. And for everyone here on the call, I think hopefully you can tell everyone is excited to be speaking with you and also to answer any questions you might have. So feel free, if you have specific questions that might be more lab focused or student focused or course focused, to add questions in the chat or save them till our Q&A period. But let's get started. So what are we going to talk about? First, we'll give you an overview of the space engineering program at York. We'll talk a little bit about some of the courses in the curriculum, just kind of highlights. We'll introduce you to some of our facilities, which are really cutting edge, give you an idea of the employment and co-ops that students will go on, and mention some of the space engineering focus clubs. So to give you a quick kind of overview, we have a space engineering Bachelor's of Engineering, Honors Bachelor's of Engineering program at Lassonde. It's particularly unique because it's focused on space systems engineering and instrument design, which is a very interdisciplinary space. We're taking materials from mechanical engineering, electrical engineering, systems engineering, computer engineering, and we're synthesizing all of these different disciplines to be able to really create a program that allows you to excel as a space engineer, but also as an engineer in various complex disciplines. And you'll see that some of our students will go on to not just space engineering as a career, but other areas as well. It is one of the oldest programs at Lassonde, founded in 2000. It standalone in 2003. And then as soon as it was able to be accredited, which was 2007, it's been accredited ever since. We also have some unique options. So in addition, if you take space engineering, you have the opportunity to do the mechatronics certificate, which is only offered right now to space engineering students. And so in addition to being a space engineer, you'd also graduate with a mechatronics certificate if you take a few courses as part of electives in your upper years. You also have the opportunity to do the best certificate in entrepreneurship, or do a dual honors degree with international development studies. And so a lot of the stuff that we do in space engineering, such as Earth observation and space solar power, things like that, can lend themselves really well to being able to support international development studies. So a really unique opportunity there as well, and graduate with 2 degrees. Space engineering at York is also the only space engineering program in Canada. So you might have heard of aerospace programs or programs that allow you to specialize as an option into aerospace, but those focus on both aeronautics and astronautics. So space engineering is really unique that it is the only program in Canada that gives you the space focus that you need to be able to really get the upper hand in this field. So what is that space focus? Well, we actually allow you to simulate, design, train you to build and test instruments, payloads, and as you heard from some of the students already, get involved with actually flying missions. And so preparing things in our clean room, we'll talk about facilities, get to actually get hands-on prototyping. Can you see my cursor? Yeah, okay, great. Doing different kind of setups to be able to test electronics, test hardware, plan things out, do tests on balloons. So we get kind of these cutting edge experience with software like STK, like NX, where you're learning what the industry is actually using. You get hands-on experience in labs and experiments. You also get to do mission design and payload design courses. We also have active space missions, so not just missions that students are working on, but we have missions like the OSIRIS-APEX and the OSIRIS-REx mission, the NASA Ice Mapper mission, things that are kind of up on the horizon, where our faculty are actually working on NASA and Canadian Space Agency projects that are actually flying. And ultimately, space engineering is one of those great areas where if you're interested in multiple disciplines, you're going to get background in many different areas. So between mechanical, electrical, computers, materials, we integrate a lot of these disciplines to be able to be effective space engineers. So what are some of the space courses that you'll take? So while there's lots of courses that come together to kind of create those foundations, We have a space systems engineering course that really is focused and kind of introduces you to the whole field. In the upper years, you're going to have space communications, physics, materials, and dynamics for space vehicles. You also have space hardware, payload design, space mission design, and you'll have the opportunity to take electives in space systems courses as well. In addition to these, we also have the new mechatronics courses, which we are offering through space engineering. So the introduction to mechatronics and the mechatronics systems and design courses. And so those are really hands-on, exciting mechatronics courses that you can do, that you can apply with space, but also more broadly to other robotics and mechatronics types jobs. Okay, facilities and labs. And so this is where we have a video here, but we don't want to watch an 8-minute video. So I'm just going to show you some of the little clips here of different equipment. And I'll actually let Ian talk a little bit about the facilities and equipment that we have, since he does a lot of the running of these labs and coordinating of these labs. So I will just kind of turn off the sound here and let this play in the background.
Yeah, okay. So this is a first year lab. My colleague Lalita is demonstrating different kinds of flow using, we call these our virtual sandboxes. You can see she's playing with the sand, and so she changed the gradient to see how water or precipitation might affect the land because of that. This is me in the one of the space engineering labs. I'm here working with one of our control systems. So we use the Quasar Aero for a 4th year control course. So you can think of it as a bit of like a helicopter or a drone. Here I'm using some electronics equipment. So this is a spectrum analyzer, oscilloscope, and function generator. We'll use this heavily in 4th year, but also a bit in 2nd year as well in your electronics courses. Here's our anechoic chamber. So we use this to test antenna characteristics. So you can think of it as a room where similar to like a sound room where the walls absorb the sound. Same thing here. Here we absorb the RF radiation. Here are a few of our 3D printers. So as part of our new mechatronics certificate program, in 3rd year, you'll have an opportunity to use, do a bunch of different designs, and you'll have access to these 3D printers amongst other equipment. Here's one of our ground station antennas. So we use this to also do antenna characterization, but also use this to track weather satellites. And also celestial objects like Cassiopeia A. Here's one of our vibration cables. You'll use this in 3rd year. This is part of a shake and bake test. So when you are launching a satellite or something into space, it needs to survive 2 things. It needs to survive the rocket launch. So this is to simulate the rocket launch. And then we have a thermal vacuum chamber, which simulates the thermal environment of space. So we suck up all the air and range of temperature between minus 140 and plus 140 degrees Celsius. Thanks, Michael.
Thanks, Ian. And as you can tell, like a lot of these equipment are actually not just kind of like equipment that we would use for teaching and for labs, but these are actually large equipment items that can be used for real space missions. And some of them have been used for testing and prototyping for missions that have actually flown. We have a number of clean rooms on campus actually do the manufacturing, the assembly, the integration of CubeSats. We also have the Algonquin Radio Observatory, which is not our facility, but actually maybe, I don't know, Ryan, if you want to speak to this very quickly. It's a really unique opportunity for 4th year students.
Mike, can I jump in on this one?
Oh, sure. Go ahead, Ian.
Yeah, so this is one of the coolest experiences that you'll have as a student. You'll get an opportunity in 4th year to design software, write software from scratch to track GPS satellites. And then we have an opportunity to demonstrate that software on a real antenna. So this is the 46-meter radio antenna at the Algonquin Radio Observatory. It's the largest fully steerable antenna in Canada. And so you'll be developing code that will spit out pointing angles and will actually command this antenna to track GPS satellites. Not only is it like a fun experiential experience, it's really educational. It's also a great way to cap off your space engineering program. Here, you do this in the last thing, 4th year. Pretty cool. You actually get a chance to walk on the surface of that dish, which is definitely a big highlight. Thanks, Michael.
Absolutely. Thanks, Ian. No, that's great. Fantastic. These are just some images of other labs here that we have. Some of the equipment you've already seen. And we have a number of research labs as well, but that you can have the opportunity to actually get involved with through undergraduate research and summer internships and getting involved in the lab, as some of the students, actually all the students are doing summer research on this call, or some type of research. So just shows you the opportunities that there are at York to actually get involved in research, which is very unique for undergraduates. In terms of kind of recent employment and co-op destinations, this is just a list of some of the places where our students go. Right now, the aerospace industry is seeing a huge surge. So they're looking for more and more students that are graduating to get involved and to fill positions in the aerospace industry. And so the aerospace industry is forecasted to grow significantly in the next 15, 16 years in Canada, but also internationally. But in general, we also have students that will go to all sorts of other companies because of the interdisciplinary type of skills that you gain as a space engineer. We now have the mechatronics certificate will also open up even more doors, and the BEST certificates, which will open up more entrepreneurship opportunities. But I can't stress enough how unique it is to be able to get actually hands-on research experience in a lab or simulation experience in a lab and be able to fly some of that work. And so some of the students will talk to you about that as they talk about their experiences. Well, there's also a number of student clubs. There's 300 plus student clubs at York. In terms of space-specific clubs, you see some images here from the York University Robotics Society. So they compete in all sorts of rover competitions. We also have Lassonde Satellite Club that's working to design and launch satellites. The Students for Exploration and Development of Space, or SEDS, and the Rocketry Club, which participates in the Launch Canada Rocketry competition. And there's actually more space clubs, and there's students that are constantly coming up with new clubs based on new competitions that have been emerging in space. And so if you've got a really exciting idea, or there's a really exciting NASA or CSA or industry competition that you want to get involved in, there's lots of opportunities to be able to start that and get yourself set up with a new club at York. So that essentially runs through kind of a high-level overview of the space engineering program at York. At this point, I'll pass it back to, I think, Anna, and we'll do some student spotlights.
Sure thing. So I'm sure prospective students who are joining us today, or those who are watching this later on, are curious about our current Lassonde students, maybe why they chose space engineering or their favorite parts of being in the program. So perhaps we can go around a little bit, and I'll have each of you briefly tell us your story, how you ended up in space engineering and what you consider to be some of the highlights of your program. Ian, if you don't mind, I'll throw it your way first, and then we can go around again.
Sure thing. So I actually found space engineering when I went to the Ontario University Fair in my grade 11th year. And I was just looking for engineering programs, and I heard about space engineering, and I had a very big interest in space, stars, star formation, solar systems, that kind of thing. And space engineering just seemed right for me. And honestly, I have enjoyed it a lot so far. My highlight so far has been watching the launch of the Essence CubeSat, which I got to watch from Florida. It was a really, really cool experience.
So for those of us who don't know what that is or need a little bit more context to know how cool of an experience that is, can you elaborate a little bit, Ian?
Right. So a CubeSat is essentially a really small satellite. We're talking 10 by 10 by 30 was Essence, centimeters. Um, and it was very emotional to get to go down to Florida and be at Kennedy Space Center with 600 people watching the launch of this satellite, of this rocket, because it was a resupply mission, but watching the launch of the rocket and just being there and feeling the energy and just watching the rocket go up was just really great, knowing that there was something that I helped build going up to space.
It's really cool, and I'm really glad that you had that experience. And I'm sure a lot of our students or those who will be joining us later on are excited and looking forward to similar opportunities. Marissa, do you want to tell us a little bit about your Lassonde journey and some of the experiences you've had here that you can share?
Yeah, sure thing. I'll just elaborate a little bit more about the Essence CubeSat mission first. So the Essence CubeSat mission was a undergraduate student-run mission funded by the Canadian Space Agency to send a small CubeSat, which was 10 centimeters by 10 centimeters by 30 to space. That was fully built by the York University students and mostly run by undergraduate students. I think Ian just missed a few things saying. So I found out about the space engineering program when I was also in grade 11, and I moved across the country to come to Toronto for space engineering. I originally lived in Vancouver, and I moved to Toronto to come here. Since then, I got the opportunity to join the Essence CubeSat mission in my first year. And then going on, I got to join Dr. Regina Lee's nanosatellite lab, and I haven't been disappointed by the opportunities this school has presented me. There are a lot of, there are countless opportunities if you just look for them to get your foot in the door of the space industry. And anyone that's truly passionate about working with satellites, rockets, or anything space related, like this school has a lot of opportunities. Other than that, there are also opportunities to do other things. Like if you don't necessarily know if you want to do space related things, or if you're doing the course and you're like, oh, I don't actually know if I like doing orbital dynamics. I don't know if I am really that interested in this. I find that you kind of learn a little bit of everything. We learn a bit of electrical engineering, systems engineering, mechanical engineering. Our first year is, well, the first year of the engineering program is the same for all the majors. And our first semester and second year has a lot of mechanical and electrical engineering courses, and that's great. Yeah, I don't know where I was really going with that, but I find when I'm applying for co-ops, I can fit the description for not just space-related positions, but for mechanical positions, aerospace engineering positions, and sometimes electrical engineering positions. It's not my strongest suit, but yeah, that's kind of my point.
Thank you, Marissa. I'm sure that a lot of us, our students or incoming students, are already thinking about co-op, right, and how to get involved. So it's great to know that there are so many different approaches students can take when it comes to getting involved and seeing all the opportunities and pathways available to them. But Connor, I'll let you kind of, elaborate on that. Tell us a little bit about how you came into the program and what you would like to share with our prospective students.
Yeah, so first, just let me know if my voice starts to cut out. My internet has been a little unstable, so just let me know in the chat if that happens. Uh, my journey is different. I am a mature student, so I came across the space engineering program when I was not in grade 11, but when I was 25 and working in retail. I came off a couple of college programs beforehand and found out that uh, I really enjoyed the math and science aspects of the programs that I went into before. And coming into space engineering, the only idea that I had was the childhood dream of like space. Oh, I want to work on something that goes to space, something that is in the space environment. And throughout the program, I've come across a lot more disciplines because people will tend to think of space as niche as a whole already. But there's space situational awareness, there's space health, there's space architecture, there's strictly robotics, there's things relating to optics, which at the moment I don't know too much about, but remote sensing, so on and so forth. And so within the entire journey, it's finding, wow, there's a lot more to do. When it comes to clubs at York as well, there's multiple avenues. The Robotics Society, as Professor Bazzacchi has mentioned, has many different avenues, and the more that you put into any club or your classes or research that you do, the more you get out of it. So in the Rover Club aspect of the Robotics Society, they have electrical teams, they have software teams, they have mechanical teams, they have science teams. So if you wanted to get into, say, an aspect of astrobiology out of all things, which I don't believe we have a class for at the moment, I think there might be one professor who knows about that in the physics department, but you could go into the Robotics Society, hop on the science team, and start learning about extinct, extent, or absolutely no life at all. When it comes to research opportunities, we have Professor Regina Lee's lab for nanosatellites and simulation, attitude control determination. We have Professor Bazzacchi's lab for, I believe it's more robotics and asteroid engineering was the main word that I remember, how you described your lab. And then we have, there's numerous, there's the Mars Ice Lab. And so there's many different aspects, and even the Lassonde Engineering Society, they have people from all different avenues that are looking to assist you with trying to find even international opportunities if you're looking for them. They've had speakers from NASA as well as just other avenues. And I think our professors here are actually the reason why Marissa, if she wants to talk about it more, did end up having an opportunity with ESA this past February, the European Space Agency. And we have been looking for other international opportunities, such as with JAXA, the Japanese aerospace, Japan's NASA, essentially. Their internships had opened back in April, but from what I could find, it seems like they're unpaid. But if you're looking for that sort of thing, and you can sort of manage the cost of potentially an unpaid internship, international different labor laws, international opportunities exist, with Japan, with Europe, which those are funded, and with the Canadian Space Agency as well. So yeah, York has a lot of opportunities, and the space industry is growing.
Thank you so much, Connor. I do want to take a pause here in case there's anyone who has a question for us before we kind of carry on with our conversations here. So if you have any question about the program or about anything you've heard so far in today's session, you can either raise your hand in the Zoom or you feel free to leave it in the chat. We are keeping an eye on it. In the meantime, while we wait for more questions to come in, I'm always curious because I'm always curious about the courses that students take in space engineering. So I'm wondering, maybe I'll actually throw it over to our profs here, if there's a course that you really enjoy teaching or your favorite course to teach, and why. So I'll kind of let whoever wants to maybe chime in here.
Regina, are you still there?
I am here, but probably not the right person to answer that question since I teach ethics if I tell the group that I love teaching engineering ethics, they might get the wrong idea. So
But-
maybe, Michael, you should jump in.
Sure, but you're teaching space mission design next year, right?
That's next year. I'm so looking forward to it, but I haven't
Awesome.
actually taught it yet. So
And I
Yeah,
will
that's
jump on that. Like afterwards, I'm sure our prospective students would love to learn more about courses that will be offered to them later on Professor Lee. So definitely hold on to that.
will
But
do.
great. So,
yeah.
Christina, I see your question, and I think it ties in perfectly with the question that Anna had just asked, which is, are there course materials related to aerospace or space vehicle design? And the answer is generally yes. So there are space mission design elements. We do have a dynamics for space vehicle course, which talks about kind of orbital mechanics and how we do sort of any sort of maneuvering in orbit, how we do control of space vehicles, whether it's attitude or orbital control. And I believe that course, which is typically taught by Professor Shan, also includes some launch vehicle dynamics as well. So these are sort of elements that all tie into space vehicle design. This past term, actually, I think I had all three of you in my materials for space engineering course, so they can tell you really what they think of the course. But that's a fun course that I taught that basically essentially exposes you to you get basics in materials, you get basics in a lot of different elements in your earlier years, but as you get into the upper years, we start saying, how does that actually work when you get into the very harsh space environment? So can we put a 3D printed part into orbit? What's the consequence of that? Will it outgas all sorts of material and clog up your sensors and things like that? Will it totally change shape on you because of the vacuum environment and because of the heat characteristics? These are things that we talk about in that sort of course. What are the effects of all these different space environmental effects on your materials as you design your space vehicle? So whether that's a satellite, whether that's really anything that goes into space. And so that gives you one example of how that kind of from my personal teaching of how that space vehicle design gets brought into the different courses. But that's true for all sorts of different perspectives. So when you're thinking about space vehicle design, things like space communications is extremely important, right? How do we communicate with those space vehicles? And when you start getting into sort of payloads and payload work, there's a whole courses on space hardware and payload design, which are really critical to being able to effectively have any sort of hardware on orbit or on other planets. So hopefully that answered your question, Christina. If not, feel free to follow up. Great.
Professor Lee, did you want to maybe tell us a little bit about the course that you're looking forward to?
Well, again, I haven't taught the course yet, but I've been waiting for a long time to teach this course. It's actually a very unique course that we teach both second and fourth year students together. One part of the course is about space systems engineering, where we talk about how satellites and other vehicles that we design are basically a system that we have to look at a systems engineering perspective. In fact, a lot of things about space engineering is also can be referred to as a systems engineering, and we do have graduates who are practicing engineering in that field as well. The second half of that course is about mission design. So any space mission tends to be a very, very long process. Some of us in the graduate lab is involved doing about 5-year mission design, development, and implementation, AIT, the whole 9 yards. And we try to do that in 12 weeks. So it's a very compressed course in that sense, but we actually cover from object definition, so mission objectives, all the way to the launch and operation. So it'll be a compact course, but at the same time, we actually cover a lot. I actually do plan to have a few guest speakers coming from the industry, practicing engineers who've been in space industry for a long time to come and talk to us about their experience. So I look forward to it. And maybe in not so far in the future, we hope to do this in even more compressed fashion, maybe in a summer or maybe in a project setting where we actually get our hands on and build a CubeSat. That's in the works, so maybe it'll happen. We've been talking about doing a CubeSat project as part of the curriculum for a long time. So with some more effort, maybe we can put that into a program as well.
Great, thank you so much. There's so much to look forward to. I feel like, we, even on the teaching end, we're all still learning as well, right? To see how to keep up.
Yeah, and
And
actually, sorry, Anna, to cut you off,
no,
but I just wanted to jump on what Regina was saying, which is, I think it's key is that our program is also very tied to industry. And so the faculty all have very close connections with industry partners. We have advisors from industry that help shape our curriculum, so that way our students are prepared for the jobs that are actually there for them when they graduate. And so even for myself, I'll be teaching space vehicle dynamics, I believe, this upcoming year. And previously, I've brought in speakers from industry and from NASA as part of who have been doing, flight dynamics for 20 years or doing attitude control and design, and actually talking about their experience and showing how what we're learning, either fundamentally or the stuff that we're doing in the classroom, how that actually applies to what you'd be doing as a career. So I think that's really cool about space engineering anyway.
thank you. I'll now.
Let me throw Connor under the bus a little bit here. He's actually doing internship with the Magellan at the moment. What's so different about it now that you're in the semi-industry setting? Anything different? It's all the same?
Sorry, I just want to make sure that was directed towards me. I cut out for half a second. So I mean, instead of just, I guess, using the simulation environment that, of course, PhD student Ryan Clark had developed in the lab, and being just within the lab environment, getting help from other PhD students, now it's legitimately going back and forth with, oh, this is the industry partner, this is the person I'm working side by side with. They have their own tools, techniques, and developments. So you have to work in, okay, what is the naming scheme that they have for variables in coding now? How are you going to track and log your work as you're going through the entire process? The more questions you ask, the faster that you tend to pick up and learn new things. It's one of those things that you learn really fast is you might feel smart on the inside if you're not asking questions, but overall to everybody else in the room, you're going to look like the fool at the end of the day if you're not asking those questions to actually put in the work that you need to put in come the end of the day. The main thing, I guess, with industry is just now it feels a lot more serious overall. It was serious before, but now it's like that deadline is right there. That it keeps you on your toes.
Okay, thank you.
Very, very practical, I think, insight and advice for all current and prospective students, I'm sure. I guess since we've heard a little bit from our prof on the students' end, if there's a course or an aspect of your program that you really enjoy but hasn't come up yet, or you feel like it's a little underrated, this is your moment to share, to kind of help shed some light on it. Any takers?
I actually wanted to mention about the space mission design course that Regina was excited to take. I actually took it this winter semester, and it was a really, really cool experience because I was seeing where I was 2 years ago in the students that are second years, and seeing how far I've come from the understanding I had in second year, where a lot of things I didn't know. It's plain and simple, did not know things. To being a fourth year, or well, third/fourth year, and having the knowledge of a lot more things. It's just a wonderful experience, which is absolutely aided by the fact that the project that we were working in that course was quite interesting and very applicable to what could be a future mission.
Great. Thank you, Ian, for sharing. Coming of age, right? Some growing pains along the way, but I think like everything in life, we learn and we grow bit by bit. And I think this is a program that really helps allow that and nurture that in all of our students. So thank you for sharing. Again, I want to encourage anyone in the chat or anyone who's part of this session today to ask a question or give any comments about anything that you've heard. But I guess I will end off, if there are no other questions, with kind of a general question. What advice, or I guess adding on to Ian's point about perspective, what perspective or insight would you give to a student who maybe is just entering engineering this coming fall, or thinking about entering engineering very, very soon? I'll let anyone who has something top of mind speak first, if you're ready and willing to share.
I can go first. I don't mind. Yeah, for first year engineering, work hard, but also have fun. Don't make the courses your entire life. But also make sure you do well in your courses and just show up to class. It's very valuable to show up to class, and a lot of people don't do it.
Valuable advice, Ian. I do see there's a few questions in the chat. So before we continue giving advice, there is a question about Space Resources Roundtable. Is that anyone aware of this or could give some insight into this? Maybe we're not the right group for this, but if you'd like to expand, feel free to in the chat and we can look into it. Or I'll also leave. Yeah, go ahead.
No, the Space Resources Roundtable, are you talking about the one out of the Colorado School of Mines or the ISRU one? Okay, yeah. So, what is your specific question? I mean, I definitely heard of it.
Maybe we'll give him a
I would say indirectly. So I've had students go down and give talks during so they tend to have conferences and sessions as part of larger conferences as well. So for example, they'll have like a symposium as part of the AIAA SciTech conference. And so I've sent students down to give talks on research related to space resource utilization. But I don't think York has any formal connection with it in terms of other than just like faculty or students being engaged with it, if that makes sense. Are you excited about space resources? Because I am too. So if you are, that's great. Awesome. Yeah. So if you're, I mean, there's a lot to go over and there's a lot going on, but my part of my work and my research is actually looking at asteroids and how we can utilize those materials, or lunar materials and how we can utilize those materials to expedite space travel and space exploration and deep space missions. So yeah, very exciting stuff.
I want to jump in and suggest that maybe you to look at the Canadian resources. Like there are lots of Canadian societies, groups, gatherings, meetings, conferences, workshops, roundtables going around. There's one coming up called CASI Astro. It's really meeting of all the Canadian minds, and that's where a lot of industry and academic partners come together to share ideas and network. I think it's actually happening in Toronto. Type that in the chat. I will. See if I can find the link. It's not that expensive. It's by the airport. Oh, somebody already did beat me to it. So if you want to just go to one gathering, this might be it. If you want to just stay local and meet a few people, a lot of York students will be attending as well. I'm sure everyone will be submitting abstracts very soon, and we'll probably see you there.
Wonderful, thank you. And then back to Christina's question there about advice for first year engineering students or what to focus on throughout the summer. Ian, I think your answer of taking a little break is great. And also perhaps, reviewing material, brushing up on calculus, physics, and chemistry. On the admissions front, Lassonde is also unique in that we offer something called Lassonde Academy. So for all of our admitted students, we offer free virtual pre-university courses over the summer before you begin your studies here in the fall to brush up on these exact topics that Ian had just mentioned there. So keep an eye on your email. You're going to see instructions or steps on how to register for these free courses very soon. You would have also received a little blurb about it in your digital starter guide in your email. So take a look for that. If not, we're going to send out more information soon. But that's also a way to, if you'd like to just learn a little bit more or brush up on skills at your own pace over the summer virtually. We also offer that through, like I said, Lassonde Academy. But any other advice for our students, for those who are excited to join us?
Well, if nobody will say it, I'm gonna offer the invitation out there. If anybody wants to come by, we would be happy to greet you at York. Except for Connor, the rest of us are all in the area, and we can always meet each other in the lab, show you around, and talk to you one-to-one. So give us a call. We are all on the York Atlas. If not, then I'm sure Anna can send you our contact information. So do come by. We'll be
Yeah.
happy to see you on campus, even if it's not a formal tour or anything.
Yes, and actually on that note, I can give more information about our tours as well. And so if you reach out to me or any of our department representatives today, we can try to set you up for a special peek into our labs and facilities. But you can also sign up for one of our Lassonde tours where we have our student ambassadors show you around campus, show you all the unique spaces that our students have access to every day. And on that note, I want to let me just pull up this slide right here, just because it might be easier for everyone to see. So there are several ways for you to continue exploring Lassonde. So whether you are curious about other programs that we offer, or you want to learn more about the student experience, or simply you just want to stay in touch with us before you join us. If you scan the QR code in the top right-hand corner there, you'll be brought to our Discovery Days page where you'll be able to sign up for tours, see our schedule for other spotlight sessions, or we also host Ask Me Anything or a virtual drop-in. So Ian Porto, is our student ambassador, is also part of those sessions. Or you can join us on Discord. We have our current students and our Lassonde experts in there answering any questions that maybe you didn't get a chance to ask today. So again, thank you all for joining us today. If you have any questions for us, please feel free to connect with us through Lassonde community, through email, or we'll see you at a future session. So we look forward to seeing you all very soon. Thank you very much.
Thank you. Bye, everyone.
Thank you.
Thank you. Bye. Don't hesitate to reach out.